So, hi everyone, let's learn about polynomials now. So you'll find this on pages 8 to 14 of your book. Much of this you'll be familiar with from Math 2B. So I'll just really say some of the things that are a little bit new here. Okay. So the first thing is that we need to know what this word polynomial means. In Swedish, it's polynom. So just this first 7 letters here. Okay. So examples of polynomials are shown here. 2x plus 1, 5x squared minus x plus 2, x cubed minus the square root of 2 multiplied by x plus pi. Okay, so if we have a polynomial, then we have various terms where x has a different exponent in each term. But the key thing is that the exponent for x must always be a non-negative integer. Okay. Now constants, we can think of them as being multiplied by x to the 0, because any object except for 0 raised to the 0 power has a value of 1. So then it would be 2 times 1, which would be 2. Okay. Here we have some non-examples. So 2 divided by x, if we were to try to write this in exponent form, then the x would have an exponent of negative 1, which would be a negative integer. So then it would not be a polynomial. Okay. Also, square root of x, if we write that in exponent form, then the exponent is 1/2, or 0.5. So again, that is not a polynomial, then it's not an integer. The Swedish for integer is heltal. And we know that pi is not an integer. So then this is not an example as well. Okay. Now, one key word that comes up a lot is degree. In Swedish, grad. Okay. So that is the largest exponent that x has in the polynomial. Okay. Usually we write the term of highest degree first. Okay. So here this would be a degree 3 polynomial, because this term we have x with an exponent of 3. Okay. This one has degree 2, because we have x with an exponent of 2 as the largest exponent for x. And this has a degree of 1, because x is another way of saying x with an exponent of 1. Okay. Now, what I've talked about here are polynomial expressions. If we have polynomial functions, then really they just, we use the same principles that we've used for other functions. Okay, so that is that then this expression is the function expression. Okay, so if we have f of x is given by this function expression, and if we want to evaluate that, find the function value when x is 2, then we substitute 2 in for x, just like we've done in the Math 2B and 1B courses. Okay, so on those pages 8 to 10, you'll be able to practice, evaluating polynomials and substituting and so on. So let's look at the next things now. So on pages 11 to 12, you'll learn about multiplication of polynomials. So really, this is largely reversion of what we did in Math 2B, that we have these 3 formulas. In Swedish, these are called första quadreringsregel, andra quadreringsregel, konjugatregel. Okay, and also in Math 3B, we'll work with these formulas a little bit more, and maybe some bigger formulas like a plus b cubed here, where the exponent is 3, or a minus b cubed. And you'll find formulas for those in the formula sheet. Okay. So really, in terms of kind of general principles, there isn't so much to say about this. It's just something that you have to just, practice a lot, and where, accuracy is everything. Okay. Now on pages 13, 14, we can practice factorization of polynomials. Okay, so we can do this either by finding a common factor. This was supposed to be highlighted, but it almost looks like it's erased now. But anyway, finding a common factor. So if we have x squared plus x, we can say the x squared, that is x times x. X, we can view that as 1 times x. So then when we factor out this common factor, then we have x times the x plus 1 times the x. So you can say in total we've got x plus 1 times the x. Okay. Now the other method we'll use for factorization is using one of the formulas from the formula sheet. So if, for example, if we can get something and identify this sort of pattern and know what A and B are, or this one, then we can write it in this factorized form. So this is the factorized form. This is the expanded form. If we're given something that has this form, we rewrite it in this form, then we've factorized that expression. And you can practice that sort of thing using these rules. You can practice that in questions 1129 and 1130. Okay, so thanks for listening.